Okay, I'm going to come in here and trench in close to the axis, and then just round over the edges and knife edge both ends. Here is the stock piston minus the 2 holes that we already drilled with the drill. And then this is where I'm going with it. I already did the one side. And I blended this in here and started blending the rest of it. I did find out that that little piece in here that wasn't in any of the other spots was actually the backer for the locating pin for the lower ring. So that's what that was. So again, from there to there. I'll do the rest of it and we'll take a wait. Okay, tear out the scale. Piston is now 42 grams. So we've narrowed the skirt on the intake side, touched every surface on the inside, made these windows, raised the skirts on the side, and just a second I'll put it in the bore. Here we are in the lighting. Hopefully that focuses. The intake side is towards us. You can see we've brought the skirts in so they're almost flush with those transfers. They could go a little further. I'm just not comfortable doing it. And the exhaust is already flush. You can see how much that's opened up in there. Be very evident after we open the case up more. But that piston should flow. And here, in contrast, is the little red barn piston that we did not use. And I think that makes a really good comparison. Okay, I think I'm finally done crankshaft, taking a little bit more out of the sides and the leading edge. Pretty happy with the way it looks up here. I'm happy with the rod, and that's definitely different than factory. Let's see how much total we've removed. Okay, the crankshaft here showing 348 grams. Originally it was 371. So we've removed 23 grams in total. Okay, I just did a little bit of simple math here. We had taken 6 grams off of this 371 off of the connecting rod side. So I took our 47 and our 42 on our piston, which is where we are now, and that's minus 5 grams, and then minus another 6 grams on that connecting rod side is a total of 11 grams off of the reciprocating mass, if you will. And then our 371 minus the 6 that we took off the connecting rod side was 365, are now 348, so 17. So we've taken 17 grams mostly off of the counterweight while taking 11 grams off of mostly reciprocating mass. So our overall balance isn't too far askew, allegedly, but I have seen some formulas online that say you only want to remove half as much mass off of the counterbalance as you do off of the reciprocating mass. But that would be you'd want to remove half as much mass off the counterbalance as you do the reciprocating mass at 180 degrees to the reciprocating mass. You could remove a whole lot of mass here at, say, at 90 degrees. You could remove probably 5 grams here to 1 gram here. So I still don't think we've overall affected our balance greatly. Most of the material removed here has been right in here and in the leading and trailing edges of the counterbalance itself. Again, I don't know that I've done anything to improve it. I definitely haven't done anything to increase longevity, but I'm trying something here in the attempt to make a better running saw with increased power efficiency, if you will. So that's where I'm at. This is what I'm trying. If it fails, then maybe we'll have a chance to see the point of failure, where it happened at. I wanted to do a comparative view here. This is piston work done, no port work done, no opening up the lower transfers yet. Point out a couple things. On the exhaust side here, our piston skirt lines up with the transfers the way they came. On the intake side, we've brought this edge around so that it now almost lines up with the transfer. So we've narrowed this skirt quite a bit. And here you can see just how large these windows seam in here now. There's a lot of room for airflow. And just to contrast that, let's look at the little red barn piston in here, where the only chance for airflow is when this piston is pumping down, what can spill over the edge of the skirt and into the transfers. And then that would be coming up against that blunt-faced crankshaft as well. Let me just grab the crank, we'll add it to this picture. Okay, I'm gonna try to convey this on video. Here we're at top dead center. There's our piston. You can see as if we were to fire and the crank would be rotating down, the piston's coming down. Here the piston would be compressing the airflow in the crankcase and trying to force it through those side transfers, those open transfers. But right when we get to this point here, our counterbalance on our crank would be blocking the airflow into those transfers as we continue this rotation around. So this right here is when we're trying to fill our cylinder with a fresh air charge, but we're also blocking our fresh air charge with our crankshaft. So for those reasons, that's why I've come in and opened up the sides on this piston so much and added these windows that weren't previously there. Here you can see we actually have quite a bit of room for airflow in there, and we'll increase it more when we start porting this lower case. You can also see where the knife edging of the crankshaft here helps disrupt that airflow less. That's still a big blunt face coming through right here, but we rounded it off as much as we can. Alright, back to more grinding. Here is the little red barn piston, and I'm trying to showcase how much it blocks the transfers in comparison. And actually, I can't get it to go through a full rotation in this motor without hitting the crankshaft. I would have had to clearance it anyway. So Like I said, we'll definitely do something with this piston in the future, just not this particular build. You can see how those counterweights get right in the way of the airflow right when you need it there.